Alright, Tracy, so for the first couple of these problems, you can actually use some of the notes within your spreadsheet for the hypothesis testing for a mean. That'll help you determine whether you are doing a left tail test, right tail test, or a two tail test. In this instance, the average American consumes 10 liters of alcohol per year, and then they're asking, does the average college student consume less alcohol per year? State your null and alternative hypothesis. Well, our null is that the mean of the average American consumes 10 liters. So the mean is equal to 10. Well, then an alternative, they're asking less alcohol per year. So in that instance, our mean is less than 10. So right here again, you can use these in your spreadsheet to kind of help you out. A left tail test, the alternative hypothesis is less than a certain number. In a right tail test, the alternative hypothesis is greater than a certain number. And in a two tail test, the alternative hypothesis is not equal to a certain number. So it's just different. Well, in this case right here, if your null and your alternative hypothesis is P is equal to 0.44, and alternative is P is not equal to 44, then in that instance, it's a two-tail, because again, a two-tail test, the alternative hypothesis is not equal to a certain number, and in this case, H1 is alternative, and P is not equal to 44. Now moving on, in a hypothesis test, you conclude the result is statistically significant, and we could reject the null hypothesis if, and again there's notes in the spreadsheet that can help you out with this, if P is less than alpha, you can reject the null hypothesis. But if P is greater than alpha, you fail to reject the null hypothesis. So in this case, the p-value is less than or equal to alpha because we could reject the null hypothesis. So if we're able to reject the null hypothesis in this, that must mean the p-value is less than or equal to alpha. Now in this instance, the p-value for our hypothesis test turns out to be 0.05874 at a 10% level of significance. Well, the level of significance is alpha, so in that case, our alpha is greater than our p-value. So in that instance, just looking at our notes, and remember, if the p-value is less than alpha, reject the null hypothesis, and if the p-value is greater than alpha, fail to reject null hypothesis. So in this instance, alpha is 10%. We only have a little over 5% here. So, knowing that our p is less than alpha, we can reject the null hypothesis. Now moving on, I sent over some notes with this video to help you out with different types of errors doing these. But regardless, doing this problem here, we are looking to decide, what kind of error this is. So I'm going to get some of these extra problems out to show you the different types of errors. So in this instance here, a 2011 survey by the Bureau of Labor Statistics reported that 91% of Americans have paid leave. In January 2012, a random sample of 1,000 workers showed that 89% had paid leave. The resulting p-value was 0.271. Thus, the null hypothesis is rejected. It is concluded that there has been a decrease in the proportion of people who have paid leave from 2011 to January of 2012. What type of error is possible in this situation? So, we reject the null hypothesis, and with a type 1 error, we reject the null hypothesis that is true. So in this case, the null hypothesis is true. So we're doing a type 1 error. And then if you want a different instance where it isn't true, let's see if I could get you one here. Alright, so getting back to this question, with it being a type 1 error and type 2 error, neither or both, I sent you over some materials with this video to help you out determining this. But just know, in a type 2 error, increasing the sample size is one of the better ways to reduce a type 2 error from happening. Let's move on here. A hypothesis test that used to see if less than 5% of all Americans would still drive to work if gas prices went above $10 a gallon. The p-value for this test was 0.03. We can conclude that 3% of all Americans would drive to work if gas prices went above $5. So in this instance here, it's going to be false. And then for the last question, suppose the results indicated that the null hypothesis should not be rejected. Thus, it is possible that a type 2 error has been committed. Given the type of error made in this situation, what could researchers do to reduce the risk of this error? And again, reducing the risk of this error, since it's a type 2 error, by increasing the sample size, you can reduce the chances of that happening. So that's what we would select. Alright, I hope this helps.